All right. So today's short course, that's what we're going to start calling them instead of a full course, because this is part of our membership benefits, basically,
Right.
is on connector types. And although this may be, pretty common information, a lot of you guys have already been exposed to what connectors are and such. It's kind of a basic course, but I wanted to go through and show the various types of connectors that I've come across or that many people use. There's probably a lot more than I'm going to show you that's out there. So this will at least give you a general idea and concept of it. And then we'll talk about why connections are important for our work, especially. Okay. So the importance of good connections. Obviously, if you don't have a good connection, then there's going to be problems associated with your landscape lighting system or any electrical system in general. But typically, um, if you go out to a job site, you're working on a project, or you get a call to do a repair, it's most always going to be in the connection is where you're going to find the biggest amounts of problems or your biggest point of failure. Because a lot of guys don't know how to do real good, strong connections. And again, depending on the type of product that you're using. Back in the old school days, like when Mike and I first got started, everything was exposed wires, wire nuts, tape. I mean, it was pretty bad back in the early pierced connections,
Yeah.
which we're going to show those. But now, obviously, through I guess, some failures that have happened over the years, they've started making better connector types for us, so it's less likely to have a problem. So that's a good thing. Poor connections, can cause fires, meltdowns, and obviously failures to where the operation of the light will not work. We're going to talk about that. The reason being is the amperage, the current that's flowing through the cables. If it's a weak or poor connection, it will generate a lot of heat, and heat causes fire ultimately and all the problems. Um, I always suggest, use a good quality proven connector that will ensure that your system's long lasting and endures, the longevity of the system. Don't cheap out on connectors, basically. Again, there's cheap ones and then there's real expensive ones. And unfortunately, they're not I think most connectors nowadays, in the packages that you buy, they're going to be anywhere from, let's say, 50 cents a piece to several dollars a piece. So if you've got a lot of connections to make, you can see how that's going to add up, especially if they're like $2 a connector set, or $4 a connector set. So it's a cost that you just have to plan for in your bidding. So then that way, you're using good quality stuff. So how do meltdowns and fires start? And then we talked about this just a minute ago. It's basically poor, weak physical connections of the wiring. Um, that's what's going to cause the heat production. So if you don't have a connector type that you can actually cinch down or lock down, let's say with a physical connector like a screw, um, or some sort of a clamping mechanism, then it's easy for it to slip or to be loose. Because as the cables heat up or the wire heats up, when the electricity's on, it can cause expansion and contraction, and therefore it can become loose if it's not a strong connection. I just mentioned there it's mechanical connections are best. I'll show you those. Don't settle for the cheap, inferior, weak ones. So let's talk about amperage. Amperage is basically what's considered current, and it's the flow of electrons through a conductor or in and around the conductor. Amperage is what generates heat. So high current flow will cause those meltdowns. If you noticed on transformers, most transformers today that we use, They have a rating inside. It's a 25 amp maximum um, flow through before the breaker trips. There's an internal breaker usually on most transformers, or a fuse, or depending on the system. And if it goes above 25 amps, that's what protects you and your system. Is it's supposed to shut off, so then that way you don't melt down the whole system and then start fires. So, but I've seen systems before where it may not trigger or trip, and you'll get high spikes, high current flow through cables. Like if you get a short in your cable where one positive side's touching the negative side, or the neutral side of the two wire system, then that can cause a short, which will spike up a high amperage load through there. And I've seen cables before, I don't know about you, Mike, but up to like 74 amps flowing through a low voltage cable run.
Yeah.
That's scary.
You can grab the wire and it's hot.
It's hot. Yep. I've seen
One side. Yeah.
Yeah. I remember one time I was on a job, and our guys, they did something, and we turned on the system, and I'm looking out and I'm like, is that like fog or mist? And it was actually, there was a short in the circuit, and it was the smoke. Smoke was coming off the cable. It was melting down the jacket on the cable.
Yeah.
Luckily,
Yeah.
we caught it in time, before it was installed. But I'm just saying that's how hot it can get. That's why they melt down real easy, and that's why fixtures have caught fire. Another thing that you'll see and hear about every year, and it's that time of year coming up, holiday lighting. Look at what's going on. I mean, how many homes have you read in the paper that have caught fire from holiday lighting because of something happening, whether it's a short circuit or they've overloaded all the wiring on the house, and those things, they'll burn down real easy. So
Yeah. Yeah. Yeah.
So if you look at, Ohm's law, I mean, not to get all technical and into the engineering side of things, but that's, it's an inversion calculation between watts, amps, and volts. And you can see the formula there that shows the inverse action of it. If you take those two measurements, you can always calculate what's missing out of that puzzle. But to show the example, if you have 120 volts versus 12 volts, that's a 10 times difference. Okay. So in amperage, let's say you have an example of 80 watts on your system. So 80 watts, and you have a 120 volt system, let's say line voltage, then it's only 0.7 amps basically that's feeding through there. Versus if you have 80 watts and a 12 volt system like what we're doing, it's almost 6.7 amps. So it's 10 times difference. It's greater. So that's why we have to be careful. I mean, even though it's safe, most of the times you can hold the wires, you're not going to feel anything when the electricity's on a 12 volt system. The amperage though, if you do, like you say, you cross those wires, you'll feel it right away. Like Mike said, it'll burn your hand. You'll get scorch marks on your hands easy.
Yeah.
So
Yeah.
just be careful. That amperage is the killer.
Mark, so what caused that situation you're talking about? Was it just a bad product, or what
No, it's
caused that one?
typically most products, obviously, before they go out of the factory, should be either tested or their function right out of the box most of the time. I mean, you'll know if something's wrong, but there are occasions where even right out of the factory, I've had this happen where the fixture's not working, nothing's, and you go and check it and it's got a high amperage load on it. Well, internally, the wires may be touching somewhere in the stem or at the socket assembly or something weird like that's happened, right?
It's rare. Yeah.
It's rare, but you'll know when it does happen, or maybe the system will trip, and then that way you'll know, well, I just put that new fixture in. Oh, well, maybe that's the problem. And then you find out, sure enough, it was.
Samuel, usually I've only seen this happen when we use halogen lamps, not LEDs. Okay.
Okay.
Halogen, you know, if you put, it's usually a homeowner that goes out there and replaces you know, a 20 watt halogen lamp with a 50 that he bought at Home Depot. And he does that all the way down the line. And then all of a sudden, yeah, you get that surge. It's like current,
You've
it's
overloaded the system.
overloaded the whole
Yeah.
thing. So
Okay.
I'm surprised it didn't trip at the transformer, but it does not always, you know. So
Yeah,
you know,
and one of the things that we try to, I know Mike and I, we've been through like the stuff at the AOLP where we did the CLVLT training and stuff. You should own a, you know, a multimeter or like an amp probe and
yeah,
voltmeter. So then
both.
that way you can
Yeah,
test your system once you install it, make sure, find how many amps are running through, you know, each circuit or at the entire transformer and such. So then that way you know what the system load is before
yeah,
you leave the job. You know, ideally, like on a, let's say a 300 watt transformer, I think they're, what is it? Like it's less than 3 amps that I think is allowed on that one. But you can check, you know, at the transformer, like I said, there's ways that, and that's another class in itself, but you know, you just want to make sure that you're not going to overload your system. Whatever the system rate, if it says, you know, maximum 300 watts, just like you see on this chart here, cable. Let's just use this as the example because that's why I put this on here. If you have a 12-2 cable, you know, the maximum rating on that cable for low voltage or any 12 gauge wire is 20 amps maximum.
yeah,
That's the maximum on that size cable. So we always suggest, and NEC does too, I believe it's like between 80 and 90%. Just go with 80% as your
yeah.
safety.
Stick with it.
Whatever that rating is at 20 amps, then plan for no more than 16 amps on that cable run,
Yeah,
if
yeah,
that makes sense.
yeah,
So, and then you look at all those on 14.2, 15 amps max, 16.2, 13 amps. And then, you know, nowadays we have cables coming out of the factory, like your wire leads from the fixture. They're all like 18 gauge cable,
yeah, yeah,
sometimes even 20 gauge, which is even smaller. So
yeah.
you're going to be less than 10, 5 to 10 amps maximum on there. So you got to be careful. Again, if you're piggybacking a lot of fixtures and things like that, let's say, not that you're going to be doing that all on that small gauge of cable, but just you've got to know what your cable limitations are when you design it too. I think, I don't know about you guys, but I use 12 gauge at least for all of my home runs going out, unless it's like a one or two single fixtures, like let's say isolated on a patio cover and the transformer's close, then I might run a 16.2 home run to it, a cable feed. And then when I get out there, and let's say I have a junction box or a hub box, they call them, then I branch down to a 16.2 cable, usually feeding to the fixtures,
Right,
each
right.
individual fixture. So there's different cable design methods that you can use, but you know, again, know what you're working with, so then that way you can determine where, you know, either to limit your problems or where problems may occur. Do you have any questions on that, Sam?
No, I definitely I understand the general principles there. Um, as far as you seem to like to use the hub and the junction. Can you
Yeah.
explain like where, if you've always done that, if there's something that, you know, converted you to start wanting to use that? But
It's kind of an old school. Well, I don't want to say old school, but when I first learned, everything was daisy chain, the T method, which is like a main cable feed coming out, and then you split off, and it's like a T,
Go
you know,
both
where
both
you,
directions. Yeah,
right. There was the loop method, which then you had to worry about polarity issues from positive and negative. Otherwise, it
hated that.
was a problem.
Yeah,
Um, what else was there back in those early days? I think those were the main ones right there.
right.
But then when unique lighting came out, and this is Nate Mullen, when he created the first multi-tap transformer, for our industry. So he's a very innovative guy. He came up with this method, well, called the hub method. Now, I think probably electricians have been doing other methods like that in the past, because Nate was an electrician back in like 85 to 90, that time frame. So he may have learned some of this from those early days, but that was basically the hub method. They also call it like wagon wheel, spider hub, they call it different things, but basically it's a main feed going to a junction point out somewhere in the property and then branching off 25 to 30 feet maybe in any direction. That's basically what the hub is.
Yeah.
So, and I've always liked that. It was made things a little simpler and easier to, at least for me, to like, okay, zoning wise, I always liked it for zoning purposes.
Yeah. Samuel, we just did a job. We're actually still on it, but the distances were so far from the transformer. It was like 250 to 300 feet from the transformer before we hit some trees. So we had an irrigation valve box and we ran 8-2 wire to that hub. And then after that, then we went off a 10 or 12 gauge wire to the trees. That way you have very little voltage loss from the transformer, especially using 8-wire. Okay.
Yeah.
It's huge.
Yeah.
And then we didn't have to worry about any of that stuff. So yeah, that's the last time we've used that. So yeah, but it's just,
I'm sorry. Go ahead.
No, I'm good.
No, I was just gonna say we're gonna have an actual class on wiring like methods.
Yeah.
So we can show some of these things, because there are situations you may have a big project, or like Mike was saying, really long distances. So there's techniques or there's ways to get yourself enough power to those points based on like use heavier gauge cable like that, go longer distance. I do things where I go out to a hub and then I may feed from the hub to what I call sub hubs.
Yeah.
Like Mike just talking about, which is maybe I go from like an 8 gauge down to 10 or a couple 12 gauge cables feeding off, and then you do it again to the fixtures. So it's like chained, it's like a spider chain. But it should work. I mean,
and it does,
because if again, if you're feeding everything back to the larger size cable, which has the heavier load rating, number of watts that you can put on those cables, then it should be fine, as long as you're not overloading. You got to go back to your transformer again. Like most transformers, only on the common side, only allow you to go to 300 volts or watts. I'm sorry. Thank you. On the common. So they may give you like 2 commons.
So you have 600
watt or whatever the case may be. So you've got to be careful that you don't, again, 80% roll, that's 240 watts max that you can go into the transformer. So so there is some science, or there's math to this. But if you're doing small systems, front yard, it's got 10 to 30 lights, you may not have to worry about much of this. You just want a basic size cable and you're good to go, So all right. Hopefully that explained that okay, but that just know your cable sizes and what their limitations are, and and then you'll be fine. So short circuits, we've already kind of talked about this. It's where a live wire or conductor touches a neutral, and this will set off an electrically unstable situation, high amperage or high current. And then you can see in the photo, that's what happens. The jacket will actually melt and it'll expose all the copper strands or the copper wire directly. And then that's what, again, heat builds up, and then fires start. Okay, let's look at now types of connectors. I tried to classify these based on the style of connectors, and then I'll show you pictures of a lot of variations or versions of these things. So there's wire or twist-on connectors. These are like your basic wire nuts, okay? Some are silicone filled, some are not. Some have a variation where you'll have a grease tube or some sort of surrounding tube to keep that all protected inside and waterproofed. So we'll look at some of those. Crimp connections, these are good, better than the twist on wire nuts. Wire nuts are good, but you've got to be able to seal them properly so that water doesn't get in there. And you also need to ensure that you have a really good connection when you strip wire and you're not losing strands of copper for one, but also that you can yank on that connection and it's not going to pull apart. A lot of guys, when they do wire nut
strength, tensile strength, tensile strength.
Yes.
Yeah.
So it's a lot of guys, you need to learn how to do good, strong wire nut connections, whether you use them or not. It's a good practical proficiency you should have. Same with stripping wire. I've got some wire here and some strippers. I can show you how I do it if you want to see that. It's again, it's just something. Well, yeah, why not just do it right now? So like, I don't know if you can see these different size cables. So like here's a 12-tube cable.
Mm-hmm.
And then right next to it, this is our 16, little, I know it's not, there you go.
Hold it back towards your face. There you go. Yeah.
Right. Can you see those okay? And then on this other side, these are even smaller. Yeah. I got it. I should just do a recording on this so you can see.
That's okay. Sorry.
These are both 18 gauge cable. Can you believe that? Look at how this one's so much smaller than this one. But it's the thickness of the sheath, the sheathing on it. That's how much extra plastic's on there. So make sure, and there's descriptions written on the side of one side of the cable that will always tell you what the cable size is and the maximum voltage. I think everything's always like 300 volts maximum for low voltage cable.
Yeah.
But it'll have on here 30 volts for the cable, and then they'll have the UL standard usually listed on there. Let's see what other information. Sunlight resistance. I mean, there are different grades of cable, okay, made for direct burial. So, for example, on stripping, so if you can see me, like I'm gonna do a little pre-cut down the center between the two conductors. Okay, and then you can pull it apart. And then when you take your strippers, don't go straight down, go on like a 45-degree angle. This is what I was taught when I went to electrical class. So then that way, when you actually cut into it, you can pull right off, see, without losing the strands on the side. So if you practice on that 45-degree angle based on the setting on the side of the strippers, like if it says 12 gauge, 16, it'll have different settings, then you should be able to pull that off without basically stripping away the copper. Does that make sense?
Yeah. So you're saying the actual sizing on there is expecting you to use that 45-degree angle?
Well, it's a technique. I don't know if they teach that much. I had an old school guy. I took this at a junior college years ago. This guy who's a master electrician. Electricity will kill you. I mean, he was like getting all intense and put that down. Don't touch that. And I mean, he was like screaming but he was one of those old school guys, really good, really smart. And anyways, that was one of his techniques. He said, instead of going straight down, like on a perpendicular to it and you cut, a lot of times that will end up, some guys they'll push too hard and they'll cut through some of the copper strands.
Yeah.
So if you go on a 45-degree angle to it,
it increases the thickness of the rubber.
Yeah, and then it's easier. You just push on the back and it'll just slip right off.
Oh.
It works pretty good. Just practice, all these things, just spend time and just take some scrap wire, practice on it, see if you lose any strands in the process.
Yeah.
And that should help.
Yeah.
So let me show you now with like on wire nuts, there's different sizes, different colors. I'm gonna show you a chart on that, but just with these two, you know, this was another thing my instructor said. I don't know why he said this, but he said line the wiring up to where they're this, you know, don't twist them. I like to twist them. I twist them all the time because I kind of like figure, well, I'm going to pre-twist.
Get it started.
Yeah, that gets it started. But instead of just sticking the nut right on, then I'll take my cutters and I'll cut it,
Trim it off.
cut. And then that way you get a nice, even, strong bite. You start twisting. And now you notice I'm holding the back of the wires here and I crank these down, you know.
So you can't do it anymore.
Yep. Just get them as hard as you can. So that way you can pull individually, yank on these wires and they will not come apart. They shouldn't come apart.
Yeah.
If they're loose and come apart, then you know you got a bad connection.
Yeah.
Okay. And there's other things, you know, like on some, like the big gray wire nuts for like 8 gauge and stuff like that. They're a pain to work with. Sometimes what I'll do is, you know, you take your channel locks or something and you can take those and crank them, you know, down like that way. I like these little ribbed wire nuts better than or the wing locks, they call them. There's like a wing wire nut. Those help too, but you can crank it around more with a pair of channel locks or something like that. So that's all that is. But now another thing that I will say with wire nuts. So I'm going to show you these versions. There's ways that you can they have these tube connectors, which you can dip these inside of, which is filled with silicone, clip the tops on it, and then it's a done deal, right?
DBYR.
What's that?
It's a 3M product.
I think so. DB 400s or then there's different model numbers for them.
Sure.
But you know, you can always, I do this. See this product here?
Scotch coat.
It's Scotch coat is what the electricians use. It's real sticky and messy, and it's like a resin.
Mess your hands up.
Oh yeah, and it takes forever to get that off. This is easier to get off. This is called liquid electrical tape.
Yeah.
By Starbright. I buy it at like Home Depot and Lowe's, you know. They have it in different colors. I usually just get black. I use this on like butt connectors. And we're going to show these in a minute, but if you can see a butt connector.
Samuel, I told you about those.
Yep, I used them.
Good.
These little butt connectors. Can you see that?
Yep.
So it's just a little metal tube in there, and then this one actually is insulated. And then you crimp it down. But I will coat those if I have to use them with this, because this is like liquid electrical. It's like a rubber. And you paint this on over the ends and on the, whatever, and it will dry within like 10, 15 minutes.
Yeah.
Wow.
And then that will waterproof it. Now, is this a permanent, long-lasting solution? Probably not. I think after time, I mean, I've been using this stuff for probably 8-10 years now. And I check it every year I go out. Like there's some connections I've had to make in trees where if I didn't use like a lighting shrink type with the heat shrink connection, and I had something like this where it was a repair or whatever the case may be, then, you know, I always check it and I'll maybe recoat it. I also use this stuff on the back end of down lights specifically, or on well lights at the bottom, where it's exposed to like the earth or to the wherever water can possibly get in. Okay. If you want to use silicone, you can. It just takes longer to dry. I've used this. It seems to work pretty good. I haven't had too many problems with it. So
Mark, I've used it for 45 years in irrigation.
That's
45 years.
Wow. Nice.
Yeah.
I mean, it's, you know, what's sad, since this whole, you know, not to get all political, but I used to buy this for about $6 a can.
I know. Now
it's $12.
You got to go on eBay to find it now.
Yeah.
So here's the connector that we use.
Yeah.
In we used to. We don't anymore. So it's just a hang on. It's just a crimp connector. That's all. Okay. And then We put the wires in there, twist them, and then fill this with Scotch coat.
Yeah.
And I've had systems in the ground for 40 plus years, never a failure. Okay.
That's the old school electrician method.
That's Frank from Canada. Remember him?
Oh yeah, yeah.
This is what he used,
Okay.
and it's like, well, I've been doing that forever, So yeah, this is one we use. You can buy these anywhere, Home Depot,
it's just
whatever.
messy. That's why I think a lot of guys probably don't like to do
You have to
them.
wear gloves, and then we use this is the tool that we use.
Okay, yeah.
To crimp them. Okay.
Oh, nice.
Do that. There we go. Okay, and we just crimp them down. This is an Oetiker crimp connector, and we use it for clamps. Oetiker is a German product that makes clamps for irrigation.
Awesome.
So yeah.
Thank you for sharing that.
Yeah, I bet.
Very cool. So crimp connectors, we'll show you these, but there's butt connectors, there's sleeve type connectors, there's piercing connectors or connections.
These terrible.
Are the old school ones I was telling you about, where they're like a little barbed or like a piercing point piece of metal that punctures down in through the cable jacket, and then it will touch or be embedded into the copper strands. That's how they work. The problem is when the wiring heats up and cools down, then that will expand and contract. That sometimes will come loose. Then acts like, oh, look at the bad connection. It's not working. Those are not the greatest connectors.
Yeah.
But that's the old school ones. And a lot of companies still throw those into the box with the products for you to use.
Kistler used to. Yeah.
Yeah. Barrel lug connectors. These are mechanical connectors, and they have usually some sort of a lockdown screw, whether it's a straight slot type, or a hex type. And I'll show you these examples. So we just looked at the, quick wire connector, but see the wings on these, that helps to twist them. Then they've got the ribbed types here, which again, same thing, that will help to, if you're using a pair of like channel locks or whatever. These are just regular wire nuts. Each one, the colors are typically uniform. Yellow is for a certain size cable or cables. Reds for the next size up. Gray's bigger, and then obviously blue is even bigger. These are the silicone filled ones. You see they've got a little end cap, so you basically put your wires, twist them together, shove them inside there, twist it down. All the silicone oozes out as well, not all, but some of it. And that gets all over your hands too. I don't like working with those. I found that they tend to come loose over time. Again, same thing, but whatever. So that's wire connectors, twist on. Here's the chart I was telling you about. You'll see these on the bags. If you buy wire nuts, they'll give you this type of chart. It's a UL type chart, and it'll say, okay, you can use 1 to 3 number 12 size cables or wires to fit into that wire nut. Or you can use 2 number 14s with 1 or 2 number 16s. So that's how the chart works. And then again here, remember I was telling, look at the colors of it shows you there. It makes it easy so you can, I need to buy more yellows or whatever the case may be. Here's some crimp connectors I was telling you about. These are the regular non-insulated ones. Usually they're out of aluminum. Sometimes you'll find them in brass or sometimes even in copper. They're a lot more expensive when you buy the brass and the copper ones versus the aluminum. But then again, you're dealing with different types of metal. If you want to really get into the details of metal, different metals react chemically with each other. So let's say you're inserting copper and it's exposed to the aluminum. What kind of reaction will you get? Will that cause some sort of a galvanic or some sort of a reaction chemically to the other metal, corrosion or whatever? I don't know. But again, if it's sealed, it shouldn't matter so much. It's only if moisture gets in there, or water or air sometimes. But
Yeah.
this is an insulated one. All it is just a plastic or a PVC type sleeve that wraps around it. Usually that gets compromised anyways. When you crimp it, it'll break through that little plastic shell and then expose that little metal on the underside sometimes. These are terminal connections, the ones off to the right, where, you know, some of the old transformers, like a single tap, like a 12-volt type transformer, like Malibu, the old, or Hampton Inn or whatever at Home Depot, if you ever use those, they'll just give you 2 terminal screws at the bottom, or 3, or whatever it is. And sometimes if you have just bare wire and you're feeding a small system, let's say, or maybe let's say it's a barbecue setup. You only have a couple lights in around a barbecue and you have one of those little cheapy transformers under the barbecue center. It's best to use those type of terminal spade clamps like that, or connectors. Crimp those onto the wire, because then that way you get a secure connection underneath that screw at the transformer. Versus if you just twist the wires and try and fit them around the screw, you'll have straggler copper wires sticking out. Sometimes, or a lot of times, I've seen it where guys cut extra on that or leave extra length. They're touching, they're crossing over, causing shorts.
Yeah.
Because, you know, they're touching the other side, the next terminal screw. So use something like this. That's going to help you to prevent any kind of possible damages to your system. Here's the crimp connectors. So typically, like, it's a copper little sleeve like this. And then you put your wiring in. This is showing just solid strands, but let's imagine if it's stranded, it doesn't matter. This tool that's up to the top right, that's your typical crimper. See how it has one side's rounded, the other side has a little whatever projection, so that when you push down, it'll crimp. See this, how it indents on the copper to
Yeah.
hold, does the mechanical connection on there.
Like light shrink.
Yeah, exactly. Lighting shrink uses this type of deal. They work fine, but you just got to make sure, double check when you're done crimping to make sure it does hold and it doesn't slip the wiring inside, because it only has one side that's pierced down. Now this tool here is called a Buchanan tool. This is what a lot of electricians have used over the years. It's a great tool. That's what does this. It's a 4-sided crimp, right? And this punctures down on 4 sides, and it's a really good solid connection.
Never seen it.
Oh, I've seen it a couple times. I don't actually have one. I'd like to get one, even though I'm already past most of my installation days.
Oops.
But it's a great crimper, and it does a good job. If you're doing a lot of crimps, this might be the way to go. And then they're solid. So here's the Pierce connectors I was telling you about. They come in different styles. I'm going to show you a couple. So you can see here, you'd slip your wiring into each side here, you know, after you strip it. And then you flip this lid over onto the top, and see that pushes that metal down in, and on the other end of the metals, the teeth that pierce down into the wire. And then that's what holds it. But it's not not super secure. It will come loose. Here's another one. You can see this. I pulled this example off the line. So you put your wire, run it through there, and there's a couple pierced barbs in there. And so when you put the wire in there and you thread that up into the rest of the assembly, then it punctures through the wire, same thing. So it's just showing you, these are the types. I'm not fans of this, but
those are the ones that fail.
Here's another one, same thing. This is just smaller, low budget one. You know, you just clip it over and it punctures down. These are the newer ones here that you see, the middle one and the one to the right. So like you see these orange levers, you'll flip those levers up, you'll strip your wire, you slide them into these gray ports here. Okay. And then you push that back down, that pushes the metal down, it pierces through the end of it, or it grabs it at the end. And then same with this one. Strip it, push your wire in there. You flip this clear part of the lever, or I'm sorry, the yellow, flip it down in line with it, and then that basically clamps it in there or it punctures through. I'm not sure how the assembly works on the inside, but I've seen it.
And Kishler adopted that and
Yeah.
sent it out with fixtures years ago.
Yep.
And I swear to God, every one of those has failed because water gets in through those tubes
Yep.
and the silicone, if you don't do it right, and it just corrodes it, you know? So,
Well, the other thing is they're bulky. I've been to a couple repairs where one of my competitors, I won't name him, but he has these all up in the trees, and you see these big old bulky connectors hanging off the side of the tree. And I'm just like, wow, what is that? And they're not sealed, like you said, but you know, that's what it is. So
stay away. Stay away.
now these are really good.
Yep.
Right here, this is the old school, what they call the ace connector. Nightscaping used to use this back in the 70s and 80s, you know, when they first, well, they were around in the 50s, 60s, 60s at least. But it's a barrel lug, which is a piece of metal. So in this case, you're seeing brass here. And then down here, this looks like it's I don't know if that's it might be copper or it's just aluminum that's been like anodized or something. But regardless, they've got set screws in there. So they're either, like I remember I was telling you, straight slot, or they're going to be the hex or the Allen wrench type. And then you crank those down onto each side of the wire. You know, this right here is the heat shrink element, the black sleeve that will have like an adhesive on the inside of that tube. So obviously, before you put this together, you got to slide that down each side of the cable. So you need two of those, one for the positive side, one for the negative side, down the sleeve of, or the sheathing of the wire. And then you make your connection, then you pull that back over the top of it. And then you need to heat that up with a torch or some sort of a heating element to cause it to shrink down. And then the sealant will ooze out and it waterproofs that assembly.
That's a great connection.
Yeah, they're really good.
Yeah.
I personally, I would like to do more of these instead of the crimping style. These are more expensive.
Yeah.
But they're a great connector. The other thing I like about it too is, let's say, I mean, having these set screws like this, I think the advantage to me is that if you ever needed to go out and change those out, or you can reuse them.
Yeah, you can cut them out.
Off the old heat shrink,
Yeah,
and then cut that out and reuse those barrel lugs. There's no reason why you can't. Crimp ones you can't. Once you crimp them down, they're done.
Yeah.
So they have to be thrown away. So this is the advantage to having something mechanical like this that you can, you know, tighten and loosen up.
And Samuel, I use, because I can get it in my little heat shrink kit, I use a creme brulee torch or a chef torch.
Oh, the little rounded one?
Well, they're just it's a little torch that chefs use to burn stuff, you know.
Oh, okay.
Yeah, creme brulee, whatever. Put a crust on something. I use those, and then I have an extra can of fuel in the bag, and then you don't have a huge torch you're carrying around. It's just this little thing, you know, and it works.
Good idea.
Yeah.
Because those torches, they're big, they're bulky. They're benzomatic or bunzomatic. I can't remember what it's called. They've got the automatic igniter on the end. It's like a
sure.
Or butane.
And we use those in irrigation, but for lighting, just a little teeny torch you put in a bag with all your other, connectors. Yeah, it works out good.
Nice. Something else I was going to say on this.
Sorry.
No, that's okay. No big deal. All right, let's keep moving. So here's some of the other package type stuff. This black one to the right, I forget what they call it. It's like the Nautilus or something. Polaris, I think it's called. Those things are monsters, but those are probably like just for the two. connector right there, that's probably like a $6 piece, maybe
Yeah.
$8, $10, $12. I don't know what they run now.
Yeah.
Great connect. It's all rubberized around the perimeter. And then it's got those cap plugs on top so that you can lock down those screws onto the cables. I'm sure you still have to seal that somehow if it's underground, I would think, versus just leaving the cable, but water will still get in there. But
Yeah.
anyways, here's another modified version of that. Same thing, slip your stripped wire into each side, and then you tighten those down, flip that, and close it. I would assume that should be potted in something, like silicone or whatever, because water will get into those. I would assume. So here's your lighting shrink assembly. And you can see here it's in the field, and these work great. I use them all the time. If this do you like to crimp versus not crimp? That I guess is one of the questions is these are probably less expensive. They are less expensive than the mechanical, like the lockdown type lugs, the barrel lugs. But these were pretty quick. They work pretty fast once you learn how to do it. So see how they've got the heat shrink tubing on each end of the cable. So once you make your connection, then you slide that over, and then you heat it up, and it's a done deal.
Yeah. That's what night lighters uses almost exclusively.
Yeah.
Is that. Yeah.
It's a good system. I like it.
Yeah.
Oh, I know what else I was going to talk about. I'm sorry. Is some guys used to, in fact, one of my competitors, he was touting that he would do the pinning of the wire to waterproof it. Like how they take the pot of like solder and stuff like that, where you solder the ends of the wire.
Yeah.
Do the connection and solder, and then that seals.
What a pain in the ass.
Yeah, it's a good solid method, but again, who wants to carry that stuff around and try to deal with that?
Burn yourself, man.
So there you go. Let's see. Oh, here's remember the DB400? I think that's what these are called here. It's basically you get like an interior type tube that's plastic or whatever it is. Silicone's inside that. And then you have this outer shell for this that slides over this. So, and then you've got your crimps. So basically, this is only good for 3 wires though.
Yeah.
And you have to use 2 sets of these for each side, one for each side of the cable. So you take your positive wires and feed those into here, crimp on the connection, then you slide that wiring inside the gel, and then you push that shell around it, and then it's a done deal. That's for each side. They're bulky, they work, and they're solid, but you can only get 3 wires in there, or unless, let's say you have one 12 gauge and maybe you've got 2 or 4 smaller, like 18 gauge wires that maybe you can fit 2 or 3 in each one of those holes. It's just a little more work, and they're kind of a pain,
Yeah.
But it's a good connector system. It's just you're limited on how many you can do. Here's the other one. You see the wire nuts here. You do your standard wire nut, and then with your cable, then you slide that inside this tube, which is filled with silicone, and then the cap flips over and seals it off, holds it all together in there.
That's what
you can do a crimper instead of those wire nuts. Slide that in also.
So I took a class several years ago, probably 15 years ago. Remember Vince Nalletti with Page Wire?
Mm-hmm.
That is the connector he only recommended. Nothing else will do. Okay.
Wow.
Because of the strength of it and all that.
Yeah.
But they're expensive, and they're a bit of a pain, to do. Plus they're sticking up, and how you bury them, you can't put them on a tree,
Yeah, you don't want to shoot those on a tree for sure.
That's when I took a bonding, shielding, and grounding course.
Oh wow! Nice.
For controllers and connections for lightning protection, all that. That's what he recommended. Okay. So we've used them a few times, but not very much.
I had a question on you mentioned the competitor that you had, Mark, but also like I didn't actually all my connections when I had put lights in the tree were underground still, right? Like, are
Yeah,
you guys actually making connections in the tree somewhere?
Well, it
you had a
depends on the
long lead,
products.
right?
Yeah, depends on the products you're working. Some products will say tree, like a tree light, and maybe they'll give you a 25 or 30-foot lead on it that's already done for you.
It's nice. It's
You
Mm.
nice.
do that in the ground
Well,
or
so I guess you're right. I had the like the tree mounts, so everything is housed up in there. So my
Yeah.
connections are in that.
yeah.
Okay.
Um, okay, so
Yeah.
yeah, never mind. So I guess
Did you do a Kistler mount? What was it that you
yeah,
put
the
it?
Kichler mount with
Yeah,
the little
with the
box
3
pins.
screws. Yeah, yeah, yeah.
Yep. Yeah,
Okay.
but then okay, but I didn't have any. I guess that's what I'm in my head. There's no like you can't see any connection points. It just looks like part of the fixture,
Right.
but yeah, okay. So I see what you guys are saying
Yeah.
there.
Yeah.
There's a lot of fixture companies, they'll just give you a 3-foot lead on the end of the fixture, and then you have
Mhm.
to supply your own cable from there on out. And
Yeah.
so you'll have to make some sort of connection somewhere. And if it's directly exposed, then that's where probably the best one, again, back to like something like lighting shrink or the barrel lug that's got the heat shrink over it. Those are the least noticeable
Yeah.
of them
It
all.
looks like the wire.
Yeah,
Yeah.
yeah, it all blends in pretty well
Yeah.
versus boxes versus these big tubes,
Yeah.
all the other stuff that's out there.
Yeah. Yeah.
Good question.
Yeah.
Here's another one. It's similar to the other thing. They're called Q locks. Um, these,
Not bad, but
yeah,
no.
they're okay,
Yeah.
but again, to me, a little bit messy. It's all like a plastic or composite, right? So
Yeah.
the silicone stuff is inside this part of it at the end. So when you see how they're sliding their wires in, you make your connection with the crimper or whatever, and then slide it in there, and then you use that lockdown to hold the cable in place, and then the silicone inside is keeping it waterproof.
Yeah. Those aren't bad, but yeah.
Yeah.
No. No. And they're good
So,
for underground too.
sure. So anyways, I think, yep, that's it on that. Let me go ahead and stop sharing. We're back to this screen. So obviously there's a lot of other connector types that are out there. I'm sure everybody's got their own take on things, but just generally speaking, I would recommend getting something that's like a more mechanical, something that's gonna for sure hold those wires together without movement and without any problems of slippage or whatever the case may be. So if you don't have any shorts, you don't have any failures. And the waterproof, that's your best.
Mark, I have one more.
Yep. Oh, you got
You know
another?
me. This is
Good.
what we use. This is what we use. You see it? Blazing
9500. Oh, yeah.
9500. I don't have one in front of me. Okay.
Okay.
But here's half of one. This is the bottom part right here. Okay. Here, I'll move it over. This is the bottom.
Oh, yeah. Okay.
And there's a gel or a silicone top that comes to it. And you put your wires up there and then you twist them and then fold them over here.
Oh, okay.
Fold them over and then you put the top on. And
And those won't pull apart.
Now,
then.
here's
Okay.
one in yellow. These are the small ones we rarely use. Okay, these are for like, these are for like 18 to 16 to wire. So you put your wire up in here, fold it over, and then this is full of silicone. Put that on top, and then it snap locks right here.
Gotcha.
Snaps on. So this is the bulk of what we use. Only we use the black ones because you can get, I don't know, 3 10s and a couple 18s in there, and that's about
How
it.
do those compare to the other stuff out there in pricing wise? Are they all relative?
They're less than $2. They're like $1.50, $1.70 a piece. You buy them in a bag of 12, and I don't know what they are, but that's what we use underground.
Gotcha.
Okay. It's just because we've been doing it forever. It's a blazing product, which is they're a great manufacturer. They make a lot of things. They make fittings for irrigation. They make wire connectors and make all kinds of stuff. So this is the one we use right there.
Very good. Awesome.
Yeah.
Thanks for sharing.
Yeah.
Like it. All right. Well, oh, go ahead, Sam.
Well, I was just gonna ask for a quick critique, or if you guys felt like it was too much headache or anything.
No.
So the way I did all my connections was kind of similar to that, the blue one with the cap that you showed. It's got the gel in there, and then you actually flip it down on the end. So I used a brass, like a crimp for everyone. So cut my wire, strip my wire, and then put the crimp down on there, crimped that, wire nutted that all together, and then put that in the gel, and then close the cap on that. Is that what do you guys think? Is that too much? Is it redundant? Is it
just depends on the cost, man? It sounds perfect.
You know? Yeah. Yeah. It's do the trick. It's should be a solid connection. Yeah.
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 It depends on what you like best. Everybody has a different style or things that they like. So if you like doing that, it doesn't take a lot of time. I think time's the other issue. You got to.
Yeah, I think time would be the downside to that. Is it is a little time consuming, but
yeah, it's like I always use an example, like when I do my tree downlights, I like a single point of connection. So like I use single hanger bolt, and I put my downlight on that, and I can get my pan and tilt. Right. There's other downlights in trees, but they're like 2 and 3 hanger bolts and assembly. I can knock one of those out. I can move from tree to tree really quick doing that versus trying to align 3 bolts on a tree. To me, it's not worth that time. I don't want to go that.
Yeah.
So you come up with different what works best for you.
Yeah.
Yeah.
So Samuel, we use those 3-bolt hangers from Kistler. I still have some. We use those for years, but you have to go back at least every 2 years and back those screws off, or the tree will eat it.
Yep.
The tree will eat that, and then you'll never be able to get to it, eventually. Yeah.
I could show you, I've got pictures of great ones where
Friday failures.
Well, no, I had it where, trees where I had a customer that it's a long story. They had me install the system, great big system on this property, and I was doing maintenance, and then they went through a nasty divorce. They split. They never called me back for maintenance, but then they finally did, like probably 3 to 5 years later, and they had these younger oak trees in their back where I had all these downlights, and I go out there and I couldn't believe. Like 1/3 of the fixtures sucked into the tree. I mean, the tree's growing around. I had to chisel the damn thing out. Unbelievable. That's it. They grow quick. Some trees do. So, and then you got to worry about, all right, well, am I going to hurt the tree by chipping away and cutting out the fixture?
Is the client watching me do this?
No, I took pictures. So I show the divot in the side of the tree, and then I use that tree pruning tar or spray or whatever it is, that the tree seal,
right,
to help. And it was fine. I didn't hurt the tree, but it was just like, man, it looked terrible,
man.
Anyway.
Samuel, anytime you have a question, call or text me. Okay.
Will do. I appreciate it. I really do.
Yeah.
Any other thoughts, questions that you guys want to throw out before we end? Or
I'm good.
Okay.
Yeah. I think I'm pretty good.
All right. Well, and again, like I said, this is kind of just a basic introduction to it, and there's not a whole lot you can, unless you want to get into the, what kind of plastic, I mean, but it's the idea is you just knowing what types are out there, and then finding
know what works. Over the years, you know what works. You know what works. So,
all right, guys. Well, thank you very much. Good to see you. and
Yep.
Thanks,
we'll
Mark.
see you the next time.
Okay.
Look forward to it.
See you later.
Bye,
Take
guys.
care.
Yeah.